Hello, welcome to Parametric House. In this Grasshopper tutorial, we want to make this multi-pipe model, parametric model in Grasshopper. And basically, we're going to use a cube, a box, to produce the random points and then convert it into a unified sub-D surface, which is these pipes as you can see here. Okay, let's get started from scratch. Here you can see that I can change the size of the box, which is updating the X, Y, and the Z. Then I'm going to use the Voronoi 3D, and at the end we're going to use the Multipipe to produce the final results. To get started from scratch, first of all, let me just make this a little bit smaller. What we have to do here is to make a box. So I'm going to go to this surface here and use a primitive and pick up this domain box. You can even use center box, box rectangle, it doesn't really matter. We just have to have this parametric box that we have to use in Voronoi 3D. So remember to make that box, and now I'm just going to give this a number slider, for example 12.5, and just make this Control C, Control V, and connect it to X, Y, and Z. Okay, this is basically a parametric box. We can easily control the X dimension. We just zoom in, the Y, and finally the Z. So that is really a simple box we need for the Voronoi 3D. After we made this, we have to go to the mesh. The Voronoi 3D is a great tool to make parametric Voronoi 3D cells inside the box. So you have to go into the triangulation. In here you can see there are two types of Voronoi, Voronoi 2D and Voronoi 3D. So I'm going to use this Voronoi 3D tool and give this box to the box input, which is basically the boundary of the Voronoi cells. Now we need a series of random points. We can make that from going to the vector grid, and I'm going to use this poplet geometry, which you can produce random points inside anything. So that's really easy to understand, and we can give it to a box and define the number of count. For example, from 1 to 20 maybe. We can change the number of the points we need. And then also we have the seed. The seed is really basically a random point which defines random locations for those count. We can give, for example, 1 to 100. That's going to give us 100 possibilities between different random points, which are completely unique. We don't need additional points here, and we're going to give that to Voronoi 3D. Let me just turn off the box, and now you can see that by increasing this box is going to Voronoi 3D cells. We can change the location, and that's it. To make this pattern, let me just explain what's happening here. We have to find the centroid of each of these cells, as you can see here. Okay, and let me explain this by just drawing a diagram. What I want to do here, assume that this is a 3D Voronoi cell. Okay, for example, I know it's not really the best Voronoi cell you can get, but you can get the point. Then we have this center. What we want to do is to connect the center to the area centroid of each of these faces. Okay, this is going to give us the node which we need, and also those lines are going to be connected, because if we have another cell, a neighbor cell here, for example, okay, I didn't draw this one good, so assume that this is the neighboring cell. This is also going to connect to the same point as the neighboring cell, and that is going to give us a good connection. So that is really easy, and we just have to find the centroid. I'm going to go to this surface tool and use the volume tool, which is going to give us the centroid of each of those cells. And you can see that the population and the volume is different, the volume of centroid. So remember that you can't use these population. I'm going to turn that off and use this as the center. Next one is to find each of these faces area centroid. So I'm going to go to the surface tools and use this deconstruct brep. Deconstruct brep is going to help you to deconstruct all of those cells into faces. As you can see here, some of them has 7, 8, 10, and so on. So that is going to divide that 10 Voronoi cells into their faces. And now what we need is to find their centroids. I'm going to obviously use the area tool to find the centroid of each of these faces. The good thing is that they are inside a group, as you can see here. To make it understand it better, I'm going to simplify this, okay? When you simplify, you are actually making those groups. The zeros is going to be deleted. The zeros are going to help you to understand that how many steps you take to get to this part. So it's not really important. We can simplify it. And if you really want to know about this flatten and graft and simplify things, I'm going to put a video up here so you can watch it. And also, you can enroll in our course, paracourse.com. We have a complete section about data management. What I want to do here is to, okay, we have to simplify the centroids. This is the point. We have to connect the center of the box, the Voronoi cells to the center of the faces. But if I go to the curve here and pick up a line and connect here to maybe here, you can see that this is not happening because the group of the data is different. One is inside a group, as you can see. Okay, let me just bring it here. You can see we have 10 groups, which is 10 Voronoi cells. Each of them has different faces, so 7, 8, 7, 9, and 9, 10. But the center or the volume centroid of those cells are just residing in one group. If you want to understand this, I'm going to also show you the panel. For example, just take a look at this one. This is the centroids of the Voronoi cells, and this is the area centroid of the each faces. As you can see here, all of those, I'll make that a little bit bigger, all of those center of the cells, okay, the volume centroid, are in one group, which is this, but the other faces is that there are in different groups. So it's group 1, 0, 2, 3, 4, 5 till the end. And what we have to do is to simply just graph this thing. When you graph it, it's going to produce, let me just simplify it again so you can get rid, just take a look at this. When I simplify it, those zeros are going to go, and it's going to be like 0, 1, 2, 3, and it's going to connect the centroid of this, volume centroid of this one to each of these faces in group 0, right? The group 1 is going to go to group 1, and the group 2 is going to go to group 2, and that is going to give us the exact connection we need. Let me just turn this off, and you can see it here. To understand it better, just make it 1. You can see it, centroid of a box is connecting for 2. You can see it here, and it's completely random, right? 3, and so on. And now that we have those lines, we just have to convert them into a multipipe. We have that in Rhino 7. You can go to the surface. In the sub D, you have this multipipe tool, okay, which is really great. And remember, again, we don't have to give that to the curves. You can see there is no connection. We have to flatten it because we want all of those lines to be converted into multipipes, not separately. So remember, again, if you don't know about flatten or graft, watch that video. And now we have the final results. The last part is just playing with the node size, maybe giving it a number slider like this. You can see that this is going to change the node size. The end offset is also going to change it. For the end offset, you can see it's saying, I usually use 0 and 1 because you have 2 options. 0 is going to make those connections bigger, and 1 is going to make it smaller, just like the pipe. So you can switch between this 0 and 1 thing. The strut size is the size of the naked edges. So you can play with these two, remember? And not really important for these parts. And then we just have the caps, which is for the final part. You can use between round and flat. That is really great. You will have that sub-D surface in Rhino. If you want to convert that into a mesh, you can just go here and use that mesh from sub-D and convert that into a mesh. Here you have the mesh with more information, but we are going to stick with the sub-D. And let me just give this a custom preview so you can see it better. Maybe we can go to the rendered mode and give it a better color. Okay, that's good. To see the box, I'm going to get the edges of the box. Not really something difficult to do. Just use the brep edges, and that's it. That's how you extract the edges. Now we can see the box, the containing box of the cells. Okay, different points. So if it's 1, it's like that. You can increase that. Different locations. And now we can play with this radius. If it's 1, it's going to give us a more smooth connection. And if it's 0, it's going to give a bigger connection at the knots. And then you can also change these, as you can see here. And that's it. Finally, we can just bake this in Rhino and use it in our project. As you can see here, you can use that. I hope that this tutorial was useful. Just wanted to show you a quick trick you can use from Multipipe, converting from a series of lines made from 3D Voronoi cells. Thanks for watching. Remember to like and subscribe to this channel. This new channel is going to be just simple tricks you can use in Grasshopper. And see you next time. Bye.